So in this video we're going to be doing a few examples here starting in worksheet number 2. I started this video, I hated the way I explained part 2, so I'm restarting it. But anyway, example number 1, we're going to get some numerical values. We're going to be given in this chart the velocity, selected values for the velocity in meters per minute of a particle moving along the x-axis. So we talked about that in the last lesson where these examples are going to be motion in a line. And so here we can see at various times what the velocity was, and so we're going to just answer these first two questions on this worksheet. Okay, so the first question is at t equals 0 is the particle moving to the right or the left? Well, explain your answer. Well, okay, if you look at the chart, you can see that when time t equals 0, the velocity is equal to -3. Okay, well that gives us a clear indication that because -3 is less than 0, we know that the particle is moving to the left. Okay? And then for number 2, we're supposed to try to figure out during this time interval, is there a time when the particle is at rest? And if you remember, at rest means that the velocity is equal to 0. And if you remember even further back, we know that when we have a differentiable function, which we're told we have a differentiable function, means it's continuous. And also, for a continuous function, the intermediate value theorem says that when you go from negative down here to positive up here, oh, where you can't even see it. So from -3 to +2, so this is the velocity. The velocity goes from -3 to +2. We don't know what it does in between there, but we are guaranteed that the velocity will be 0 at some point in between when t is equal to 0 and t is equal to 2. So we would say yes, because of the intermediate value theorem guarantees that v of t will equal 0 on the interval from 0 to 2. Okay, so because it says is it negative to positive, we're guaranteed. Okay, so let's take a look and see what example 2 in this same worksheet is going to have us do.